Hi everyone, it's Kira Garfolo with Tech's Math 155. Today we're going to continue with Unit 4 and talk about Section 4.3, which covers length and the metric system. As I'm sure you're aware from previous courses and just living life in America, there are two main systems that we use for measurements. We use the English system and the metric system. This happens when we're measuring distance, it happens when we're measuring volume, as we'll see, it happens when we're measuring a lot of things. When we're talking about length, the English system is primarily used in our country. This is things like inches, feet, yards, miles, things like that. Unfortunately for us, there are no standard conversions between units. Okay, that means we have to memorize how many feet are in a yard. So there's, 12 inches to a foot, 3 feet to a yard. What is it? 50 to 80 feet to a mile. Don't quote me on that. And so on. So there's nothing easy to stand by and memorize. On the other hand, we have the metric system, which is primarily used everywhere else in the world. America just doesn't get on that bus for some reason. You guys have worked with this, especially in science courses. It's preferred in science because it's used everywhere else and it's a lot easier for your calculations. These are things like millimeters, centimeters, decimeters, kilometers, meters themselves, things like that. Much easier conversion going on here. It's based on the decimal system. If we want to compare English versus metric, there's no real hard and fast rule. Kilometers are about 0.6 miles, so a little over a half of a mile. A meter is longer than a yard, but just by a little bit. And a centimeter is a little less than a half of an inch. Okay, so nothing is, consistent across those. If you want to think about it, we can think about which one is larger. We're comparing English and metric. A centimeter or an inch? Well, we just said that centimeters are a little less than half of an inch. So larger has to be 1 inch. What about a meter versus a yard? Well, a meter is slightly longer. If you hold a yardstick up to a meter stick, you'll see that the meter stick is a few inches longer. 100 yards or 100 meters? Well, if we know that 1 meter is longer than 1 yard, then 100 of each, the meter still has to prevail. Okay? Now, since everything is based on the decimals in the metric system, it's very easy to move between metric units for length, okay? I'm not talking about going back and forth between metric and the English system. I'm talking about going from centimeters to meters or meters to kilometers, okay? The easiest way to do this is to look at the difference in the power of 10, and there's going to be a table here in a minute, but the difference in the power of 10 to determine how many decimal places you need to go. If you're going from a larger unit to a smaller unit, you're going to move your decimal right. If you're going from a smaller unit to a larger unit, we're going to move your decimal left, okay? Because you're going to have, if you're going from a thing about kilometers to meters, you're going to get bigger, okay? So you're going to move that decimal right. And if you're going from meters to kilometers, smaller to larger, you're going to move your decimal left. The way that I still to this day remember this is to remember the term down right, okay? If you're going down units, so down to smaller units, you're going to move right for your decimal, okay? Here's a table, it's in your text, of the metric prefixes. You don't need to memorize all of these, but it's not given on your test, okay? So you can reference it for homework, you can reference it for practice, but you cannot reference it on the test. I will be honest with you, I have not made this test yet, but I am not going to go probably past here. So you do need to memorize these, okay? So 10 to the third to 10 to the negative third. That should be fairly fair. You can look at the abbreviations here, what the actual prefix is, and the power of 10 that they go with, okay? If you want to see the English meaning of them, we're talking about 10 of them, 100 of them, 1,000 of them, million, billions, trillions, and so on. So let's look at some examples of how we would use that power of 10. We want to change 5 meters to millimeters. Okay, so we're going from a larger unit to a smaller unit. Okay. And so we remember down right. Okay. So we know we're going to move our decimal right. Meters is our base unit, so it's going to be 10 to the 0. If we look back at our chart, we'll see that. Millimeters is going to be 10 to the negative 3. Now, if you need to look at the chart for right now, obviously that is fine. 10 to the negative 3, no prefix, it's just plain meters, and that's going to be 10 to the 0. Okay. Look at the difference in powers. So our powers of 10 are 0 and negative 3. Okay. This is 3 powers apart. So we're going to move our decimal 3 places, and we're going to move it to the right because remember down right. Okay. So we're going to have 5, and there's our decimal. 1, 2, 3. So 5 meters is the same thing as 5,000 millimeters. Okay. Now we're going to follow the same logic and do these next ones. I would highly encourage you, as always, to pause here, bounce back and forth between the table and your text and these, and see if you can solve them on your own. For the next one, we want to change 15 decimeters to kilometers. We know that we have 15 decimeters is going to be 10 to the negative 1. And kilometers is going to be 10 to the 3. This is 4 places. And we're going from a smaller to a larger unit, so we're going to move it left. Okay. So we're going to go from 15, 1, 2, 3, 4. Put that decimal there and fill in the blanks. There's going to be 0.0015 kilometers. Okay. I'll circle these so that we can find them in the mess. 0.025 hectograms to centigram. Okay. Hectograms, we can see is 10 to the positive 2. And centigrams is 10 to the negative 2. Okay. So again, we are going 4 places. 2 to negative 2 is 4. And since we're going from a bigger unit to a smaller unit, we are going to go to the right because it's down right. Okay. So 0.025, 1, 2, 3, 4. That's going to give us 250 centigrams. Okay. 14 centiliters. Centiliters is negative 2. Decaliters, not deciliters. Be careful there. Decaliters. That's just 10 to the 1. Okay. We're going from a smaller to a larger, so we're going to go to our left. How many places? Well, negative 2 to 1 on a number line is 3 apart. Okay. The 3 places to the left, we're going to start with 14. 1, 2, 3. That's going to give us 0.014 deciliters. Okay. Always look at that difference in powers of 10. You can take a subtraction, that's fine. Just remember, if you get a negative, just think about which way you're going. For this one, if we did 0 to negative 3, we would get 0 minus negative 3 would be positive 3. Okay, so positive 3, we're going to move to the right. You can think about that too. Positive on a number line goes to the right. On the next one, we had negative 1 minus 3, if you wanted to look at those powers. So that would be a negative 4. So we move 4 places. Negative on the number line is to the left. The same applies for the other 2. Now, some rules and etiquette. We do not want to use a period at the end of the abbreviation. We just simply write centimeters, for example, cm. We do not put this period here. Okay, it gets confusing when we're doing all kinds of math. Okay, we don't want to make it look like a decimal. So no periods for our abbreviations. We do put a space between the number and the symbol. This is the number one thing that I'm guilty of, because when I write them down, I don't tend to leave a lot of space. And so when I type, it carries over. Call me out on it if you see it. But you would have 6 space centimeters, not 6 centimeters, all as one word. We don't want to use plural form, okay? 6 centimeters is just 6 centimeter. It's not 6 centimeters. Look, I said just call me out. This should be 6 space centimeters, okay? Not with the S. And also pay attention to capitalization. It can get tricky because different prefixes have different symbols, and lots of other things with math gets complex. So only use capitalization if the symbol itself requires it. Liters is not a lowercase l, it is actually a capital L. And so we would use a capital L in that case. Meters is simply lowercase m, okay? Not going to be capital M, okay? Now, let's talk about measuring some things. The perimeter. So the perimeter of a region is just the distance around its boundary. You guys have probably done this in a math class at some point before you graduated high school. Basically, you're going to add the lengths of all sides. You maybe not gotten some of the fun shapes that we're going to talk about, but the basics you guys have covered. Look at the lengths of all the sides and add them up, okay? The big thing to be careful for in the real world and in this class is to make sure that all of your units are the same. You need to convert your units to be the same unit if they're not, okay? Before you do any calculation, okay? Before the calculation. You cannot undo it afterwards. If you have multiple units, unless the problem tells you a certain way, you can put it in any of the units that you want. And sometimes we're going to have to use a special formula. So if we're adding up a rectangle, just add up all the sides, right? But when we have something like a circle, we can't just add up all the sides. We don't know the sides, okay? We usually are only given the diameter or the radius. The area around, pardon my use of area, not the actual area, right? The length around a circle, its perimeter, it's called the circumference, okay? And circumference has a certain formula, which is going to be pi times your diameter, or 2 pi times r. Remember, diameter is 2 times r, so that's why those two are equivalent, okay? This is on your formula sheet, so you don't have to memorize it. Your calculator also has a pi button, so use that. Okay, let's look at some examples here. Let's start simple. Find the perimeter of an 8-foot by 4-foot rectangle. Okay, so I'm a terrible artist, but let's say that this is 8 feet and this is 4 feet. Now we know it's a rectangle, so we know also that this has to be 8 feet and this has to be 4 feet. To find our perimeter, we're simply going to add them up. 4 plus 8 plus 4 plus 8, and that is going to give us 24 feet. Okay? Now I want you to pause here and see if you can solve the next one on your own, but be careful and watch your units. Okay, we have a triangle whose sides are 4 centimeters, 80 millimeters, and 1.2 decimeters. We need to put all these in the same before we can go anywhere. I personally like to put things in centimeters out of these just because centimeters is most common. It's also in the middle of these, okay? So decimeters is 10 to the negative 1, millimeters is 10 to the negative 3, and centimeters is 10 to the negative 2. If we put everything in centimeters, 4 centimeters stays the same. 80 millimeters becomes 8 centimeters because we're going from negative 3 to negative 2. Okay. So we're going to go left because we're going to a bigger unit. 1 space. 1.2 decimeters is going to be 12 centimeters for the same reason. Negative 1 to negative 2, we're going to a smaller unit, so we're going to go down right. So 1.2 becomes 12. Okay, so now that we know we have a triangle, we have sides of 4, 8, and 12. I am no way going to draw this to scale. But let's say this is 4. Let's say this is 12. And let's say this is 8. Those are probably backwards, but we can use our imaginations here, right? 4, 8, and 12. These are all centimeters. And the perimeter, we just add up the sides. So 4 plus 8 plus 12, and that is going to give us 24 centimeters. Coincidentally, the same number as above. Now, if you had put this into one of the others, that's fine. You wouldn't get 24, okay? You would get 2.4 decimeters, or you get 240 millimeters, okay? Now, remember that the circumference is pi times your diameter, or 2 pi r. Give this one a try. We know that we have a circle, and we know that this is the radius. So our radius is 30 millimeters. So we're just going to plug it into the formula. Circumference is going to be 2 times pi times our r, which is 30 millimeters. And if we put this into our calculator, we're going to get somewhere around 188.5 millimeters. Okay, make sure that you can do that. Now, again, this is a great place to pause and get yourself some practice. I'm going to proceed. Let's find the perimeter of a rhombus that is 25 meters on each side. Remember that a rhombus has 4 equal sides. Okay, a square is a special case of a rhombus, but it can be that parallelogram, right? It can be something like this, that all sides are equal. This is terrible. But we know that it's 25 meters on every side. So if we add up our 4 sides, we're going to get 25 times 4, or 25 plus 25 plus 25 plus 25. And that is going to give us 100 meters. Okay. The perimeter of a regular pentagon that is 50 centimeters on each side. Well, remember that a pentagon has 5 sides. And regular means all sides equal. So you're going to have 5 sides. You can draw it if you want. I'm sure this is going to be nowhere near good. I'm not an artist, right? But we know that all of them are 50 centimeters. And some of you wouldn't want to draw it. You just want to know that your perimeter is going to be 5, because all sides, times 50 centimeters, which is going to give us 250 centimeters as our perimeter. Okay, now let's put together a little bit of what we've done in our first unit and what we were doing in our last unit. The length of a rectangle is 10 meters more than 3 times its width. We know that the perimeter is 100 meters. We want to find the length and the width of the rectangle. Now, this one can certainly sound tricky. It's kind of ugly, right? But it's great because we can check our work at the end, and we'll know if we messed up, okay? So we know that the length is 10 meters more than 3 times the width, okay? And the width is just the width, okay? So that means if we draw our rectangle here, we know that this is 10 plus 3w, 10 plus 3w, w, and w, okay? So we know that the perimeter, it's given that the perimeter is 100 meters. So our perimeter is 100 meters, which is going to be the sum of our sides. So w plus 10 plus 3w plus w plus 10 plus 3w. And I'm only using parentheses here to separate so you can easily see the 4 sides. They're not really necessary since we're just adding and not distributing any negatives. So we're going to know that 100 meters equals, and if we add all this up, we have 1w, 4, 5, 8 w's plus 20. And then just using some algebra here, we're going to have 80 equals 8W. So W must be 10 meters. Okay. Length and width, we've just found the width. So our length must be 10 plus 3W, which is 10 plus 3 times 10, which is going to be 40 meters. Now, if we check this, right, 40, 40, 10, and 10, our perimeter is going to, in fact, be 100, right? 40 plus 10 is 50, plus 40 is 90, plus 10 is 100. That agrees with up here. So we know that the width is 10 and the length is 40. Now be careful with these types of questions on the test because it's super easy to answer the wrong question, okay? I asked you for the length and the width. If you just give me the length, I can only give you half of the credit, right? So read the question carefully. Also, this is a check mark, not an R, okay? Now, these are kind of tricky enough, right? But we can actually get a whole lot trickier. Let's do a few of these tricky ones so you can get lots of practice. In this case, you might have to use several formulas and combine them, combine everything that we've learned so far to compute that whole perimeter. The best advice I can give you is to break that region into shapes that you can easily calculate, okay? Redraw it, draw all over it, break it up, whatever you need to do. So let's find the perimeter of this. I've already told you that the answer is 426, but let's make sure that we can verify that. What do we see when we look here? Anytime in this class, at least, that I see a curve on a 2D figure, I'm going to say, uh-oh, I'm dealing with some form of a circle, okay? So I know now I can look at this as 1/4 of a circle, right? And then a rectangle. I know also that this piece, since the rectangle has to be 70, which would also mean that this piece has to be whatever piece of the 150 isn't included. So it has to be 80. Okay. So I know this whole side. I know this side's 80 and I know this side's 70. I just need to find this little piece right here. Okay. So I need 1/4 of the circumference here. Okay. So my perimeter is going to be 80 plus 150 plus that 70 plus 1/4 of the circumference. Okay. So that's going to be 80 plus 150 plus 70 plus 1/4 times pi. And we know the radius, okay? So 2 times pi, I'm going to put the 2 here, and then times r. Our radius, we know in 2 different ways. We know that this chunk is 80, so that has to be a radius. We also know from the rectangle that this piece is 80, so it's just reassurance. Okay? So we have the edges that are given plus 1/4 of our circumference. So 1/4 of 2 pi times r. If we plug this into our calculator, we are going to get 425.7 centimeters, which rounds to 426, which is what we found here. Okay. Now, if you have a moment, wrap your head around this. We're going to get some other practice with other tricky shapes, but you should be able to see that once it's broken down. I highly encourage you go back over these after a little bit today and make sure that you can work these from a blank piece of paper. Don't look at my work, don't look at your previous work, but make sure you can get them from a blank piece of paper. That's the best way to study for math, is to practice, but not look at the solutions until you need them. Okay, let's try this one. Go ahead and pause and do it on your own. We want to verify that our solution is 360 meters. So we want to find the distance around the semicircle shown below. So that means that we need to count this piece right here. And we also need to count this piece right here. Now we know it's a semicircle, okay? So that means that we know the radius is 70, which also tells us that the diameter has to be 140 because it has to be 2 times that, right? So this length here has to be 140 meters. So our perimeter is going to be that 140 meter base plus half of a circumference, because we only have half of a circle, okay? So that is going to be 140 plus 1/2 times 2 times pi times r. Our radius is 70, okay? If we plug all of this into our calculator, we're going to get right around 360 meters, which is what the answer told us, okay? Don't make the common mistake here of just finding half of a circumference, because remember, you also have to consider the base that it's sitting on. Okay, let's give this one a try. Find the perimeter. Be careful here with units, okay? We have centimeters, we have a meter, and we have a millimeter. Personally, I think the easiest way to solve this one is to put everything into centimeters. You're going to have 500 centimeters there. 0.5 meters is going to give us 50 centimeters. We're going from 0 to -2. Okay, so we're going to go 1, 2 over. So this is going to be 50 centimeters. 180 millimeters is going to give us 18 centimeters. 250 millimeters is going to give us 25 centimeters. And then we also know from down here, since this is a rectangle, that this is going to be 500 centimeters. Okay, so this whole side down here is going to be 18 plus 500 plus 25 centimeters. Okay. Now, what do we do about these sides? Well, we've drawn a rectangle, so we know that we have right triangles. Okay. We also know that if this one's 50 centimeters, this one's 50 centimeters. Okay. So now we can use the Pythagorean theorem. Okay. Let's let this one be 1 and this one be 2. For the length of 1, remember, it's going to tell us we need c squared. Okay. So we know that the side is going to be equal to the square root of 18, because we want it in centimeters squared, plus 50 squared, which is going to give us somewhere around 53. I'm just going to leave it as 53 since everything else is in whole number. The second side is the hypotenuse of this triangle. So it's going to be square root of 50 squared plus 25 squared, which is going to give us somewhere around 56 centimeters. Okay. So this one's going to be 53 centimeters. This is going to be 56 centimeters. And so now we can find our perimeter. So we know that we're going to have this 500 plus this 56 plus all of these, okay? So plus 25 centimeters plus 500 centimeters. Here's 25, here's the 500 plus 18 centimeters. There's that one. Plus the 53 centimeters. We've gotten all of our sides now. We plug that into our calculator. We'll see that it is 1152 centimeters. Now, if you had converted everything into meters, or maybe you put everything into millimeters, you can convert your answer there, okay? So that would be 1152 centimeters would be 11.52 meters, okay? Because centimeters to meters, 1, 2. Or it would be 11,520 millimeters, because you're going to go to the right because you're going down a unit, but you're only going 1. Okay? Either of those would be correct. And lastly, let's do one more tricky one. This one's actually pretty tricky. It's all centimeters, so that's good. But the first thing that I notice is that I have half of a circle here. Okay? So I know that I have half of a circle here, which means I need this radius here. Okay? If I know that this is 90, then I also know that this is 90. That was not a very straight line, but let's pretend for a second. Okay. I also know that this has to be 90. Okay. So I need, for my perimeter, I need to add this 125 plus the 60 plus some unknown amount that we've got to calculate plus 100 plus I need a half of a circumference because I need that right there. Okay. So let's talk about our circumference. Our circumference, remember, is 2 pi r, or it's pi times d. So we're going to need 1/2 times pi times our diameter. We already know that our diameter of the circle has to be 90. Okay. So that makes it pretty simple. We only have one unknown. But how do we solve that unknown? Well, I would look at it as a right triangle situation. Okay. If I know that this is 100 and this is 125, then I know that this is 100 and that this is 25. Okay. Which also tells me that this is 25. Okay, so I know that I have 25 there. Now, this is not perfectly half, but I know that this whole thing is 90, right? But I know that this part is 60. That tells me that right here has to be 30. Okay. So using Pythagorean theorem, this is the hypotenuse again. I know that this is going to be equal to the square root of 30 squared plus 25 squared, which is going to give me about 39. Okay. So my perimeter is going to be 125 plus 60 plus 39. I'm just working around here. Plus 100 plus that 1/2 times pi times the diameter, which is 90. If I plug all of that into my calculator, I'm going to get somewhere around 465 centimeters. Now, this is about as hard as it'll get. It's about as hard as I can ask you on a test or anything like that. Okay. So if you can do this one, you're going to be just fine. There's a lot more practice in your text. Now, wrapping up, remember to be careful with your units. Convert as necessary. Before you start with any calculations, we started today with perimeter, but next we're going to do area and volume and go on from there. Do not do any of these calculations unless all of them are in the same unit, okay? Before you start with anything, it's a waste of time. You cannot go back and undo it, okay? So don't waste your time. Switch them all to the same unit. The metric system is more widely used than the English system, especially in sciences and the rest of the world, because it's a lot simpler to use. Mathematically, it's way easier to deal with. We just move those decimals around. Remember, if you're asked to find the perimeter, all you need to find is the length around that region. It can get kind of complex like we saw in those examples, but you're still just finding the length of all the edges combined. Practice, practice, practice. Remember, there's more practice. There are lots of examples in your textbook. There's practice problems at the end of each section. And then there's all kinds of resources in our Blackboard shell. If you need more help, remember to reach out to me, reach out to the Math Center, watch the videos that are also in our Blackboard shell, whatever you need to do to make sure that you get this. This is our last unit, so you want to finish strong. And I'm telling you, if you struggle with perimeter, you're not going to like the next two sections either. So make sure you have this stuff down. Thanks for joining in as always, and I will see you guys next time.